webcast from the Trusted Computing Group. I'm Mark Schiller, Executive Director of the Trusted Computing Group, and today we'll be hearing about Save the Data, how to protect data wherever it lives. We'll start with a few notes and reminders regarding logistics. First, please check to make sure you've got your PC audio on. Please note that all our attendees will be muted during the presentation. The webcast should be available for replay on the TCG Bright Talk channel shortly after we finish, and the presentation will be available there for download as well. We're planning to have time for questions at the end of the presentation. Please use the Ask a Question function to type your questions as the event proceeds, and we'll do our best to cover all of those at the end. I'd like to start by introducing our presenter, Dr. Robert Thibodeau, with Drive Trust Alliance and the Trusted Computing Group. Dr. Thibodeau pioneered self-encrypting drives during his tenure as Chief Technologist of Seagate Technology from 2002 to 2009. He has also served as chair of the storage work group in the Trusted Computing Group. Dr. Thibodeau was one of the founding directors of the Robotics Institute at Carnegie Mellon University from 1980 to 2008. He is the inventor on over 25 U.S. patents, and he holds degrees from Emory University and the University of Virginia. Bob currently co-leads Drive Trust Alliance and is CEO of Bright Plaza. I've had the pleasure of working alongside Bob over the years in his many roles in the Trusted Computing Group and in industry. Our agenda today will start with a problem statement and includes benefits of TCG standard SEDs, certification and compliance, and a sampling of use cases. I'd like to welcome Bob to get us spinning along.
Hello. So what I want to do is begin this with a statement of what we call the core problem associated that we address. But through the talk, you'll see that we actually have the capability of addressing problems beyond the core, and you'll see that. The core problem really has to do with data records that have been lost from portable and stationary devices, whether they of any sort, in any situation that you can sort of pretty much possibly imagine. And that problem has been known for years and years. When we started this process back in 1999 and 2000, our group began on it with an understanding that this problem already existed and was only going to get worse. And it continues to exist, and it continues to get worse. And this is people losing control of their data, somebody else getting it, and so forth and so on. So we have large numbers of instances every year that are occurring, and the cost of these to the companies or the organizations or the individuals is calculable by estimate, but not really calculable. It's an ongoing problem. So the problem really has sort of three aspects of it, which are critical to understand from an IT perspective. One is the legal aspect. Because this problem has been around for so many years, there are laws and regulations on a global scale that govern the presence of this technology. So if you have the technology, you'll see that there are laws that give you some reprieve from responsibility for having lost control of something. There's a financial problem, and everybody's heard of the many, many problems around there, including the loss of data records, the people, stealing your username and password, the loss of medical records, The loss, there's one that's a lot of the identity theft is sourced in these problems, in this problem of the loss of data. And then associated with all of this, which is critical to TCG, is reputation. So while there are ways that you can sort of sneak around the laws here, okay, if you sneak around them without actually attending to the problem, then you can suffer a reputational hits because you didn't really encrypt, okay, your data, and then somebody discovers that they got the bad guys got access to the data, even though you escaped the legal consequences. And so one of the problems that we address in TCG is providing a quality result that helps preserve you in the reputational risk. And of course, just losing control of data records that people trust you for. The Office of Personnel Management is an example of this in the government. Over 20 million detailed records of family members, your own past history, your family members, your acquaintances. The Office of Personnel Management was keeping records on getting clearance in the U.S. government. And of course, you have to fill out a lot of information on your history and your family's history and your friends' histories and all this other stuff. There are a lot of reports on you, and that information was lost. And that the Office of Personnel Management suffered a huge reputational hit because of that. And it's regarded as one of the biggest, most threatening national security hits that we've had in the last century, because we know that a certain very large country was the one who, or the ones who got a hold of that data. Okay, and so that's another level of the reputational. But the Trusted Computing Group is really interested in providing a quality result that the owner of the data can be comfortable that the data is properly encrypted and properly protected. So this is sort of the question of why encrypt data at rest. And the classic statement here is that you want data at rest encryption is important when you lose control of a device that has data on it. Loss of control can be as simple as walking out of the room for 10 minutes. Okay, it can be as complicated as somebody, steals the laptop out of your car or out of your at the airport. Okay. Loss of control means that for some period of time, the device that has the data on it is not in your hands. Okay, and what we're interested in is protecting sort of data at rest. And of course, most of the time, most computers do not have somebody staring at them, looking at what's going on them, and so forth and so on. So data at rest is really quite a huge place to provide a solution in the overall scheme of things. So I mentioned that the legal this problem has been around long enough that most every state in the Union and nearly every Western country and some Eastern countries have passed laws that are called data breach notification laws. So if you find that you have lost control of your data in such a way that there's a reasonable expectation that a bad guy got a hold of it, okay, or the data has been copied to a location that you do not have control of, then you're required by law in most states of the Union, on the order of 47 of the 50 states, and most countries, for example, in the European Union, you're required by law to publicly disclose that breach, unless you can prove that your data was encrypted when the device was when you lost control of that device. If the data was encrypted, you have a safe harbor, and you do not have to disclose to the public that the data breach happened. And this is the sort of the legal stuff that goes on to help people understand that they have to encrypt the data for data at rest. So in terms of the reputational stuff, the TCG standards, which are effectively the only industry standards for hardware encryption of storage devices that's out there. The standards were developed in the Trusted Computing Group, and they were developed in order to create a really important use case. The really important use case is this. If I give you a encrypted drive, whether it's a USB drive or a laptop with a drive in it that's powered off, okay, the data, and it's an Opal drive and it's been properly set up, the encrypted data in that drive cannot be figured out by even the manufacturer, unless the manufacturer can guess the authentication, the external authentication key. So what's special about self-encrypting drives is that you can't crack them unless you can find a way to guess the encryption key. An example of this that most people are familiar with that happened in the last 8 or 10 months was the iPhone situation. iPhones are hardware self-encrypting drives, and they're set up the same way. And without knowing the authentication key, you cannot get at the data on the iPhone. That's absolutely true. If you can guess the authentication key, for example, if somebody uses a weak key, a weak secret, external secret, which is what happened when they cracked the iPhone, they found out the guys used a weak key, then you can always guess enough times by machine if you figure out how to do it to get through to the encryption on the drive. But if a strong key is used, no. Nobody can get through to that drive, whether it's an iPhone or a TCG Opal drive in a laptop or on a USB stick or whatever, okay, or a server and so forth. And that's the major quality reputational piece of the work that we did in TCG on these drives. So there's a huge infographic, which is a wonderful piece of art, and it's full of good information. And we'll be covering pieces of that infographic in the next 5 or 10 minutes. But here's the pointer to it, and if you want a big PDF to play with and print it and put it on the wall, you can feel free. So the benefits of TCG standards-based SEDs are these, and we'll go through them, and then we'll see a lot of examples of this in the future. One is simplified management. And by simplified management, we're going to point out that this really has to do with, in comparison to software encryption or encryption that's not done inside the storage device. Always on security. So this is an amazing thing to a lot of people, but when the drive is manufactured in manufacturing, the day it's turned on, first electrons it sees, okay, it's busily creating random numbers which are going to be the immediate encryption keys that will never leave the drive, and then it proceeds to encrypt all data that's written to it and decrypt all data that's read from it. That never changes. So you can't tell one of these drives stop encrypting. You can only tell these drives change the authentication for this drive. But you can't tell it to stop encrypting. And you can't know external to the drive what the media encryption key is. You can't know what the actual key is. It's made never to leave the drive. So it's always on security. It never stops until the drive is thrown away, okay, burned up or whatever. It's in support of worldwide compliance regulations, and you'll see that we've been very active in both the FIPS world and the Common Criteria world in making sure that there are we support worldwide compliance with the architectures and so forth, and make the changes to the standards to make sure that the compliance continues. Breach notification exemption with safe harbor, that's easy. We don't try to sneak around the problem. We actually provide extremely good encryption, as I mentioned a minute ago. The reduction in drive disposal costs. This turns out to be one of the driving reasons, that's a sort of funny, a driving reason for much of the adoption to date, and you'll see that we've had an enormous adoption to date, because it's cheaper actually to cryptographically erase a drive than to dispose of the drive any other way. Okay, and so it just ridiculously reduces the drive disposal costs. And you see it with the iPhone. When you say erase to the iPhone, only a few seconds later, all the gigabytes of data are erased. That's because what the iPhone's doing is changing the media encryption key. And it only takes a few milliseconds actually to do that. So it's a single command in a few milliseconds, and boom, the drive is back to factory state and all the data is gone forever. It's scalable because the encryption is done in the individual drives, and each drive has its own media encryption key. You can put millions of drives, and there are instances where there are millions of drives owned by single companies that are encrypting all the time, 24 hours a day, and used in exactly that way, and without any need for central drive controllers handling the encryption. The drives individually are handling the encryption. Interoperability, a drive, because we're using the TCG standard, a drive that you encrypted on a Windows machine will decrypt on a Mac. Okay, you can, and a Linux, you can go to anything and take that same drive, and you don't have the software incompatibility problems. You just have to have the software that runs on Windows with software that runs on Mac. But the drive is the same. Access to the data is the same. There's no change of anything. The costs are here, the total cost of management savings here are enormous. It's got built-in security. It's not added on later. One way to say that is built in, not on. Another way to say it in the technical community, we call these self-protecting devices. So a TCG Opal drive is classified in the computer world as a self-protecting device. It is self-contained, self-protecting, and unless you know the secrets to cause it to give up its data, it will not give up the data. So how does self-encrypting drives compare to software encryption? And to those of y'all who've actually experienced software encryption and experienced SEDs, all of this turns out to be very obvious. For those of you who've only experienced software encryption, you really don't know what you're missing. Okay. The transparency, the encryption key is generated in the factory for SEDs. You don't have to do media encryption key management. It's just transparent and easy. Okay. It's easy to manage. The encryption key never external to the drive. The lifecycle costs, the SED costs are in the initial drive acquisition, which is at parity with non-SEDs today. So most drive makers, you pay no extra money for SED in the drive. An example of that is something called SSD, solid-state drives, where for certain classes of SSDs, the commercial bulk cost of these drives, they're all 100% self-encrypting under the TCG Opal or enterprise standards, and they cost no more. They're exactly the same cost. Disposal and repurposing costs. I mentioned that there are studies that show that SEDs just dramatically reduce the cost. There's nothing cheaper than a SED for disposing of a drive or repurposing a drive to some other place. Performance, and this is something that most people who know software do not understand. They say, well, doesn't it impact the performance of the drive? And the answer is no. The drive encrypts the data as the data is on its way to the storage media inside the drive, and decrypts it on any data that comes out of the drive. There is zero performance impact, except for a couple of microseconds of extra, something called pipeline delay, which you'll never notice. I mean, it's just not noticeable. In fact, when I was at Seagate, we had an interesting situation where the SEDs for about a year and a half, the SEDs that we were making were actually faster than the non-SEDs, because the non-SEDs had a little firmware glitch, but the SEDs tested out as faster, and I actually said that's impossible. They have to be going the same speed. And then we discovered that the problem was a glitch in the non-SED firmware. Standardization, and because these drives they use a published public free standard for talking to them, the standardization works forever. So a drive that you encrypt today, well, if you just obey the published standards for talking to that drive, 100 years from now, if the drives will still work, okay, you can decrypt the data off it if you know the authentication secret. So you have no problem with this problem. It's very common that as software changes over time, all of a sudden you can't decrypt stuff anymore. You can always go back to the standard. So a huge issue, in fact, this was the biggest driving force behind the original success of SEDs in 2006, which is retiring drives out of data centers. So there's a classic statements that are made, and the numbers vary, but it's on the order of 50,000 to 100,000 drives leave data centers, and it's probably 200,000 today, if not more, leave the data centers daily and get replaced by new drives. When those drives leave the data centers, there's data on them. If they're self-encrypting, nobody can get at that data. And all you have to do is pull the drive out of the SAN or the data center. If it's been properly mated to the servers, the drive is cryptographically erased just pulling it out. So the way that drive retirement process works, and you can go into this in more detail, but the main issue that self-encrypting drives solve is that people make mistakes. So even if they're properly trained and properly on disposal and all these other things, they won't do it, or one mistake will happen or another, and all of a sudden the data has escaped. And so what the self-encrypting drives do is just solve that problem, and that's been the biggest adoption of self-encrypting drives has been in the data centers globally, and for this very use case. So another sort of disposal option that's riddled with shortcomings has to do with solid-state drives, flash drives. So work was done out of San Diego that basically showed that the flash drives, even if you thought you overwrote all the data, or you thought that you deleted all the data on the drive, or the software thought it encrypted all the data on the drive, it didn't necessarily do that because of the way SSDs work. That it was a set of papers, and it was a work by a master's student, a guy that was trying to get his master's, that set the entire SSD community on end. And the result is that nearly every SSD that you can buy is TCG self-encrypting, because an encrypting drive does not have this problem of it's always encrypting, the data is always protected. If you change the key, the key that you lost is still protecting the key that you had before. That's gone now is still protecting the data at rest. The new key is protecting the new data at rest. It just never goes away, and so you just don't have this problem of overwriting or thinking that you deleted something and didn't delete it. You really did delete it. So drive retirement without self-encrypting drives is expensive, time-consuming, and error-prone, and this is the reason that SEDs are used so widely in data centers, and people don't even know about it. So a big piece on this slide is if you use self-encrypting drives in the fashion I just described, you get safe harbor for the data privacy laws on the systems that are properly configured and properly used. I'll give you an example of that so that you can track what I'm saying. The TCG standards provide for locking ranges. So an enterprise drive may have, pick a number, it may have 12 locking ranges. And so when a range of data on a drive is not being used by some active process in the data center, the range can be locked and encrypted and only unlocked when it's needed. So you actually get safe harbor protections out of that. And you have to be careful how you do it, but you can set it up and really gain. So, for example, in medicine, the patient data can get protected in a range in a way that you can get safe harbor protection in case somebody is able to actually get at other data on the while the system is powered up. So we'll go into the certification and compliance overview a bit. And the way we're going to proceed on this is talk about several levels of certification and compliance. One level, which is relatively new, is TCG is now in process to provide TCG certification for Opal and other standard like enterprise standard self-encrypting drives that basically certifies that these are proper Opal devices or proper enterprise devices. And we do both a compliance test of compliance on is the standard met, the interface standard met, then security evaluation. The drives meet the sort of minimal requirements we have for security, which you've already heard about in terms of even the manufacturer can't get the data off the drive if it's properly set up. And we go through an entire process on this. We've been working on this for some number of years. The certification requirements are that the drive company has to be a TCG member. They must submit the paperwork to the test lab. There's a certification application report. They must submit a security evaluation report and then submit the application fee to TCG. And the result, if you pass through all of that stuff, TCG will issue certification. There's another level to this, which is an international standard. It's called Common Criteria, which is similar to what people know of in the United States as FIPS, but it's more global than FIPS. And TCG uses this Common Criteria Protection Profile, the CPP specification, to because it's actually better than FIPS in a lot of ways. But it just gives you more assurance. It's from a reputational point of view of your own reputation to yourself. Okay, it's a stronger assurance than what FIPS would give you. So when you're getting a TCG approval, you've gotten yourself a Common Criteria approval. So the status of the certification program is that we estimate by year end we'll have the certification launch done. We've been working on this for at least a decade, but we've now finally gotten it through all the processes where the engineering is satisfied that this is a good thing, and TCG is satisfied that this is worth doing, and so forth and so on. And so that's the sort of thing. So there are lots of references to TCG SEDs out there. A lot of people have never heard of an SED. Okay, but there are references out there. Notably, things like the NIST SP800 series has multiple references. One is 88R1. ISO IEC, which is the 27000 series, which is 27,000 series of ISO documents of the International Standards Organization, which is a component of the United Nations, is about computer security. And 2740 deals with data-at-rest protection. It references the TCG SEDs. There are some newer standards. One's called NVMe, which is a very, very fast flash standard. And then another, actually faster flash standard called UFS, Universal Flash Standard, I think is what it stands for, is bloody fast, okay, and bloody good. But both of these are perfectly capable of having Opal and or enterprise underlying. So, for example, UFS actually requires TCG commands be supported. It doesn't say that the drive itself will be encrypting unless you make sure that the UFS drive is an Opal drive or an enterprise drive. UFS and NVMe are replacing things called SATA and SAS over time. The expectation is within the industry, UFS is positioned to replace both SATA and SAS within a decade. It's meeting with widespread acceptance, and part of the fact that part of the reason for it is it's so bloody fast. So TCG and NVMe, the working group that was developing, developed a short joint white paper on this, and y'all feel free to read it. The work between TCG and UFS is just beginning. We've had conversations with them. They're very, very interested. Whoever wrote the UFS standard actually provided a beautiful way to just layer in Opal technology into the drive without changing any of it. UFS, like I mentioned before, UFS is required to support TCG commands. And the 888 is about media sanitization, and they call out crypto erase as a standard sanitization. And this is how you get a variety of protections, legal protections, and also governmental protection. And ISO 27040, this is storage security, and you feel free. This document costs $75, whatever it costs to get it, but you can go and download this document and read about that. And that is now a passed standard under the ISO, as a passed as an ISO standard. And I'm not going to go into this, but you can see that these cover the main use cases that we've described. So the crypto erase stuff that we've been doing for years is really right in the center of a perfect storm. So we've got the technical definition, the only industry technical definition out there. We've got standardization that's been TCG, NIST, ISO, and so forth and so on. FIPS, there are a lot of FIPS, TCG Opal drives out there, and TCG Enterprise out there. Product proliferation, every drive maker in the world supports our standard. There's just simply no drive maker of any size that doesn't support our standard. Legislative mandates, you have the breach notification, best practices that's coming out of some of the storage, this is the Storage Networking Association, and the promotion, which has been Trusted Computing Group and the Drive Trust Alliance. We'll go a little bit into that. But we're right in the middle of it, and we're supplying the solutions out, and the success has been much more dramatic than most people have any idea. We also have real activity underway to move self-encrypting drive technology into new worlds. So one is the automotive use cases. As cars get smarter and smarter, there's going to become a problem. When you want to sell your car, it may have 15 years worth of what your kids have been doing in the back seat recorded religiously, and know every place that you've been driving to, and know all your habits and how you like to drive, and who you've been meeting up with, and who else has been in the car, and all this other stuff. And like an iPhone, you want to be able to do two things. One is when you want to be able to erase it. You want to be able to erase your car, and you want to be able to do it quick. Okay. And because you don't want to sit there and tell the car, erase yourself, and 48 hours later it says done. Okay. You want it to be a few seconds like it is on an iPhone. The second one is that you want to be able to use your car key and know that when you're getting it, when the car key is present, or the key is present or you're present, the car unlocks the data for you and not the data for your wife or the other guy can drive the car. Okay. And so those two use cases are huge, and we are currently active in this area. We actually have just finished a concept demo, Drive Trust Alliance, that showed last week in Munich at Electronica Automotive, which is 100,000 engineers. And you can see the demo at drivetrust.com auto erase and see where we're moving with the TCG standards. And that's in all TCG Opal drives. We have a variety of new mobile use cases. So the classic one is if you move your iPhone near your Mac, the iPhone will automatically unlock the USB drive that you got attached to your Mac. So this is just the idea of you've got the phone, which is a great token, and it should just be able to, when it's near your machine, you should be able to authorize it to unlock a USB attached storage device or other storage devices that are associated with the laptop. So there are really a lot of IoT use cases that are already out there. Most people don't know about this. Virtually every office quality printer copier on the market. Now, these are ones that have storage devices built into them, like either rotating media or flash drives built into them. They keep images of what they've been printing. And unfortunately, about 10 years ago, 12 years ago, disk drives from these devices started appearing on eBay, and people discovering what people have been doing in actually including top secret facilities. Okay. That caused a sea change for these IoT devices, printing devices, such that today you pretty much cannot buy an office quality printer copier that has a drive in it where the drive is not self-encrypting. It turns out self-encrypting drives was the perfect solution to the problem. You pull the drive out of the printer or the copier, put it on eBay, and it's like a brand new drive. The data's not there. It's gone. So SEDs are ubiquitous. We've already sort of mentioned that 100% of all new office and enterprise solid-state drives are TCG Opal SEDs, period. Approximately 100% of all enterprise storage, these are SAS drives or enterprise class drives, are TCG Enterprise or TCG Opal self-encrypting drives, approximately 100% today. Approximately 100% of all Apple iOS devices, and the literature is, the marketing, the press out there is wrong. Since day one of the iPhone, they've been hardware self-encrypting. There are some tweaks that Apple continues to do to improve the security around the hardware self-encryption, but iPhones since day one have been hardware self-encrypting. Western Digital is the largest USB drive maker in the world. They have about a 45% market share on all USB consumer and storage, commercial storage, and they are all SEDs. That's a 45% market share. So when you get 100%, and 45%, this ain't bad for ubiquitous. And I mentioned that all office class printers and copiers are self-encrypting. Many consumer, when you buy a laptop, often you actually have a SED in the laptop. You never know it, and nobody ever uses it. So that's an area that we're trying to repair with better software. Many consumers are based on the TCG SED standards, and now they also support something called SATA security, which is supported by TCG. In other words, we approved having an alternate way to unlock a drive besides using the TCG commands. We allow you to use SATA commands as well. And every TCG drive will support the SATA commands as well. So we're very open to making sure that there are standard ways to get at the data off these drives. And you can find the SEDs everywhere. To find the TCG SEDs, you'll see that Seagate, Western Digital, Toshiba, all manufacture TCG SEDs. Every major solid-state drive maker in the world, and this is just a sampling of the biggest ones. If you go to CES and you go up to a Chinese group and they have an enterprise flash drive sitting there that you never heard of before, it turns out you can ask the guys, so these TCG self-encrypting, and then they go, oh yeah, and then they point out where they're written that they are. Okay, so it's really worldwide and so forth. Seagate bought a company called SandForce that produces about 80% of the controllers worldwide for flash drives, even sold by the Chinese. And all of those controllers are self-encrypting controllers that are used inside the drive to create the self-protecting device. USB attached storage has been a little bit weird. while there are technically self-encrypting drives, most of the USB attached are proprietary. So, for example, the Western Digital is proprietary interface. It doesn't use those industry standard interface. But the Drive Trust Alliance has come in and sort of fix that. So we provide open source for Mac, Windows, and Linux that can be used for USB attached storage devices. And then obviously we're promoting the use of industry standard USB attached storage as opposed to proprietary USB attached storage. So the essence of all of this is that, and I hope you can see this, 1 billion self-encrypting drive technology has been massively successful. It is in use successfully. Okay. Over 1 billion people a day use self-encrypting drive technology. Every person who uses an iPhone or an iPad and every modern Android phone, okay, newer, and it has to be, it gets a little technical, but I can give people the details on this. But for example, every Samsung Knox phone is a self-encrypting phone, hardware self-encryption. All of Google, everything you do on Google, the servers are self-encrypting all the data that they're storing. Everything you do on Amazon, self-encrypting drives are protecting the data, everything, every record that Amazon keeps on you and what they're selling. Okay. Facebook, same thing. Okay. I think you hit 1 billion people a day pretty quick. So we have instances of interesting case studies, and I'm going to limit myself to 1 more minute. That's about what this will take, which you can explore. But one of the first massive successes outside of the data centers per se was Barnabas Health in Massachusetts. And what they did was they put SEDs in the laptops because of the patient data and the data breach notification laws. And what they discovered was the ease of use of hardware encryption as opposed to software encryption. And they swear by this, and there are multiple printed studies where most of the time, most companies will not talk about their successes in SEDs. They just won't talk. Okay. Barnabas was wonderfully willing to make public their successes and their analysis, and it's a great example. It's well written up, well developed, and you can actually call the Barnabas people and get confirmation that this is not a trumped up thing that they've come up with. And having said that, there are millions of seats of laptops out there that use self-encrypting drives that we can't talk very much about. We can tell you that certain governmental entities, so for example, every Air Force laptop is required to have an SED on it in the United States Air Force. That's just another example. So the summary is SEDs are widely available. You can just get them. You can type SED to Amazon and you can buy some. And little to no cost IT operations. They provide always-on encryption, no performance impact to the users, instant erasure of drives, support current and emerging data protection and safe harbor laws worldwide. They're available in many form factors. You just can't name them that they're not available in, and can be used in not only PC servers, but in any device that needs storage. And they hit IoT dead between the eyes. So these are some additional resources, and I'm happy to answer questions. Mark?
Yeah, sure. Thanks very much, Bob. We have had some questions come in during the presentation, so we'll go ahead and start fielding those. And in the meantime, just remind everybody that's on the line with us to go ahead and add additional questions into the queue using that Ask a Question function that you'll see over on the right hand of your screen there. So let's see, Bob, we're going to start with a question regarding the contrast between overwriting as an erasure procedure versus the instant erase in SEDs. You mentioned that you felt that the overwriting, the software-based overwriting, it was error-prone. If there are software programs that do claim certification or adherence to some of the particular regulations like NIAP, DOD, NIST regulations, HIPAA regulations, or Sarbanes-Oxley, why would those be error-prone if they're claiming compliance to those regulations?
So there are two instances that need sort of discussion here. One instance is solid-state flash drives, which I cover a little bit. I'll come back to in a second. And the other one is rotating media drives. Okay. Flash has cancer. Rotating media has a cold. Okay. Flash is horribly designed for protecting data, for allowing overwriting to miss the overwrites. So the way Flash has a problem, which is a flash drive, a particular physical location on a flash drive can only be written a certain number of times. If you've got a performance flash drive, for example, it's in a data center, there are some flash drives that are out there that are currently for sale that a given area on that flash drive can only be overwritten. It can only be overwritten about 10 times before that cell dies. Okay. You'll hear different numbers, but if it's overwritten 100 times. So what happens is there's something called wear leveling that goes on inside the drive. So when you write location 2024, and then you try to overwrite location 2024 10 minutes later, you may not be overwriting the same physical location. In fact, there's a high probability you're not overwriting the same location. And so the data from your first write of that location is still there, even though you thought you overwrote the location. That's what these studies in San Diego showed. Okay, and that's the reason that SSDs are almost all self-encrypting drives today, because self-encrypting drives take out that overriding error. Okay. In the case of, and that's a real cancer. I mean, that's real serious stuff. The demonstrations are there, the literature is there, and it turns out that when you think you've overwritten the entire drive, you have not overwritten it. And you cannot get, you do not have a means to overwrite all the data on that drive that's been stored.
Mm-hmm, mm-hmm.
You just have no.
Understood. So regardless of the correctness of the software algorithm, since the underlying hardware is remapping those addresses, you're potentially not touching many of those data areas. Mm-hmm.
That's right. And so unless you've had the fortune of having a perfect software encryption environment, okay, but if you lose an old key, for example, or then it can be used on the old parts of that drive, the SSD, all of a sudden you have all kinds of problems that you didn't have before that software environments don't really protect you against. And that's the reason the simplicity of SEDs just wins. The hard drives have the same kind of problem, but it's a cold, it's not a cancer. Hard drives are also logically block addressed. They're not physically addressed. In a hard drive, though, the movement of the logical blocks across the physical address space is not as dynamic. So typically, a logical block address will get remapped to a different physical area on the drive only if there's been an error generated by attempting to write that physical error, that physical data. And so hard drives have have a much smaller rate of leaking data through overwrites than flash drives, but it's there. It doesn't go away. Okay.
Mm-hmm.
So that's sort of the basic answer to this. And future drives will have the same problems. There are varieties of reasons for this, all having to do with performance and a whole bunch of other things that are having to do with how the engineering is done of these storage drives.
Okay. Thanks. That's very helpful. Another question, what about cost differences for SEDs relative to non-self-encrypting drives? Is there a premium that customers are paying to make use of this functionality?
So it depends on how you're acquiring the drives. I'll give you all a kind of an example. Remember that the drive makers, their customers are buying drives in very large quantities. And then at some point when an IT department buys a drive, he's actually buying a drive not directly from the drive maker, unless you're Google. He's buying a drive from an intermediate, like an OEM, like HP or IBM or something like that. Okay, and and of course they can price drives any way they want. And so but in the case of Seagate, for example, Seagate has a published policy that if you buy a non-encrypting drive or an encrypting drive, a TCG Opal encrypting drive, they charge exactly the same amount of money for it. There's no cost premium at all. Okay. If you buy a FIPS compliant drive, you have to pay more money for Seagate's cost to keep it compliant to international standards. That's just one example. What the end user sees depends. In some case, you can look on Amazon, you'll see the SEDs are actually cheaper than the non-encrypting drives.
Okay, thanks. Very helpful. Another question, let's see, will the TCG standards goal always be focused on the use case of protecting data at rest? And what about the issue of live unencrypted data in transit as it's coming in and out of the self-encrypting drive?
So this has directly to do with a lot of the work that the Drive Trust Alliance is doing. So what we're doing is we're creating, Drive Trust Alliance is just producing really interesting, what I call glue software that ties an SED into an environment that gives the SED surprising things that it can do. Okay, and so we actually have technology for creating extremely secure environments. We have customers that are doing that using the SED technology, and that includes data in motion. So, for example, another case is the automotive case, where we're actually protecting data. So cars are, actually most people don't know this, but most every car that's out there today is cloud ready. It's sold today as cloud ready in the sense that the car manufacturer knows how to talk to the car, and the car knows how to talk to the manufacturer. Okay. It's going to get more and more, and eventually the privacy-sensitive data is going to be escaping into the cloud, and we're using the standard Opal drives to actually make sure that the data that escapes into the cloud can't be discovered. So that's data in motion, and we have a way in which you can ensure that even the cloud provider can't get at your private data.
Mm-hmm.
So that's a mechanism for this. And then finally, we have which you all will be seeing soon, is what we call ransomware-proof drives that directly protect against ransomware and other types of viruses and so forth and so on, while data is in use.
Okay, so it sounds like we'll ask our audience to kind of stay tuned to developments in this space, and that's very helpful to know that additional work is going on there. We're about out of time for today's webcast. I'd like to thank Bob and thank our audience for joining us today for your great questions. And we look forward to hosting you at a future Trusted Computing Group webcast or event. As I noted at the outset, this webcast should be available for replay on our TCG Bright Talk channel shortly, and the presentation and other references are available there for download or access. Thanks again from the Trusted Computing Group, and stay secure out there.